My name is Scott Sefcik. I am the Vice President of Manufacturing Solutions at Stratasys. In my role as Vice President of Manufacturing Solutions, I lead a group that's focused on driving our technology further and further into the manufacturing space. People have been looking to take 3D printing, which was originally a rapid prototyping technology and has slowly evolved into more manufacturing applications on the factory floor. But now more and more customers are looking to bring it onto vehicles, be able to produce more complex parts that are lighter weight, take advantage of 3D printing's design freedom in order to build a more optimal part. But what's holding them back is the ability to simulate and have confidence that that part that they're producing is going to have the strength that they need it to have. When we were looking for partners to help us simulate 3D printed parts, one of the things that we were looking for was a tool set that was well respected within industry, something that could be trusted to produce results that were of high confidence and also be a familiar tool set. Stratasys and 10xICME Engineering have been working together for a number of years on finding the best ways to use Digimat to model additive manufacturing with simulation that represents what that part really is and how it's made. One of the biggest challenges when trying to simulate or model a 3D printed part is accurately reflecting the inside of that part. Most people, when simulating a part today that's 3D printed, make very gross assumptions in terms of how strong it is in one direction versus how strong it is in another direction. But what we're able to do, the challenge we're able to overcome with Digimat, is being able to really reflect what the inside of that part looks like, where a tool path turns, what's the gap between tool paths, where are certain geometries reflected with tool paths running in one direction versus in another direction. As customers are starting to move more and more into production with 3D printing, not having simulation tools requires them to do much more physical testing. And that sets 3D printing apart. It makes it a harder technology to use than other traditional technologies. So by being able to have a valid, validated simulation tool set, as we do have now with Digimat, we can level the playing field. We can treat 3D printing as any other manufacturing technology. And the real advantage we have with that is it helps customers adopt faster. Customers who see the value in 3D printing, who are looking to produce lighter weight parts or take advantage of the supply chain flexibility of being able to print a part when they need it and where they need it, still need those tools. And until this point, until the collaboration that we've had with Digimat, customers didn't have that option. So the industry is very diverse, and much more so than it was just a few years back. So many customers are actually surprised at what can be done with 3D printing today that couldn't just several years ago. The ability to have very high repeatability in our mechanical properties. But as the technology has moved more and more towards production, maturing the technology to the point that the first part and the 1,000th part and the 10,000th part all have very similar or the same mechanical properties. That's what moves us forward into the production space. I definitely see our work with the Digimat tool as being a long-term collaboration. We've started by providing the basic capabilities of representing a part, being able to do structural simulation, being able to do process simulation. Since then, we've built on it. We've started adding new and additional materials to the portfolio. We've started adding composite materials, carbon fiber reinforced thermoplastics, and accurately modeling those in Digimat as well. Where we go from here is even further, being able to leverage the output of the simulation back into the design, being able to leverage the output of the simulation to develop failure criteria for real parts that'll be going on vehicles in the very near future. So there's a lot more for us to do, and where we're at today is really just a starting point.